Hello friends, today we'll discuss basic about the ABB RET-670 relay. This type of relay utilized for the differential protection of transformers. It is a numerical relay, is microprocessor based relay. It is also called as intelligent electronic device. In early days, different type of electromechanical type relay used. There is no fault record in that type of relay. There is no multi-stage settings. There is no alarms, no warning about the fault. So these are the drawbacks of the electromechanical type relay. We must know what are the different software utilized for this relay communications. For ABB make relay, this is we are utilizing PCM 600. The different version will come 2.3, 2.4, 2.7 like that. For fault record analysis or the disturbance records, we are using WaveWin software. This WaveWin software will come with the package with the PCM software. Siemens relay that we are using Dixie software, that version will come 4.8, 4.85 like that. So for fault records or the disturbance record analysis, we are using Sigra software. That version will come 4.50, 4.51 or 4.5x and the later on. So like Ciprotech series relay, we can communicate with that relay using the Dixie software. For Schneider relay, like P442, P444 or P632, generally P442 and P444 utilized for the distance protection relay, whereas P632 is utilized for the transform protection relay. So this software utilizing is the MyCom S1 Studio version will come 3.4.1 like that. So for Crompton's grievous relay, that model will come like feeder control 112 or motor control 112 relay. We are utilizing the software Con Aegis 4.0 or 5.0 versions. For SCL make relay like SCL 300G, SCL 751, 26664 or SCL 387s, like 300G utilized for generator protection, 751 utilized for the feeder protections, and CL32664 utilized for the rotor outfall protections. SCL387 utilized for the transformer protection relay. For the software we are utilizing is the QuickSet, and the DRR fault analysis Synchro Wave software is utilized. For G make relay, like similar software is Multilin software is utilized for G make relay. DR actually analysis, we are actually utilizing one file. It is called as ComTrade files. It's called Common Format for Transient Data Exchange. It will come in the form of .xml, .dat, .wave or .txt. So it will contain the data and the waveform. So we'll see that ABB series different model of relay utilized for the different type of protections. That RET-615 it utilized for the restricted earthfall protections. RET-670 utilized for the differential as well as the overcurrent earthfall protections, and REB-670 is for the busbar differential protections. REC-670 it utilized like a Bay Control Unit or BCU. REC-670 is for the transfer bus coupler, wherever main and transfer bus system is there. That in that case REC-670 is utilized. RED-670 is utilized for the line differential protections. REF-615 is utilized for the overcurrent earthfall protection like 50, 51 and ANSI number 50, 51 and 67s. Instantaneous, IDMT overcurrent and directional overcurrent. So we'll consider a case of a 50 MVA transformer, 230 kV primary and the secondary, that are two tapings 11 kV by 11 kV. So different protection module. Actually in this category only we'll discuss that RET-670 relay. So in that relay we'll see that protection module or the function block utilizes for the differential protections. T3W PDIF is utilized. Like similar way, earthfall PIOC or EF PIOC1, it's instantaneous residual overcurrent for the high voltage side. EF PIOC2, instantaneous residual overcurrent for the LB1 and instantaneous overcurrent for the LB2 utilized. EF4PTOC1, these are the function module internally that relay configuration having. So EF4PTOC1 is utilized for the standby earthfall protection. It is a non-directional protections, earthfall protection. So it is having overcurrent 4PT, OC4PTOC1 That is phase over current, non-directional, IDMP type protections utilized. It has four. This indicates it's a 4 stages or 4 steps. Now we'll see in the front face of the RET-670 relay, there are 3 LED will be there. First one is the LED, it will come in the green color. Second LED, that will become in orange color. If there is any alarm, fault alarm, it will come in the orange color. Third one is, if it is coming in red color, it will be trip. So this green color, actually if it is continuously glowing, it will be healthy. So initially after power on, after 90 seconds rebooting time, and it will be stable. So if it is flashing or blinking, then it is internal error having. So if it is constantly holding, then it is a healthy relay. The front port communications, we are having default IP 10.1.150.3 and it is having subnet marks 255, 255 and 2550. In the rear port communications IP, these are all default IP. These are all default IP in the relay. So in the rear port 192.168.1.10 and default marks will be 255, 255.0.0. For similar ways, for SAS communications, utilizing the fiber optic cables, the protocol utilizes the IC 61850 protocols. So behind the relay or the rear port, you will find OEM A and B. This is the protocol utilized for OEM A, B and OEM CD. These are all utilized for the SAS communications. Now we have given supply to the relay. Now we see that ready LED is flashing now. So after the relay boot up, within 90 seconds, it will be constant. If it is continuously flashing, internal error will come. The second one is the start, and middle one is the start, that is the alarm. When there is an alarm, that will come in orange color. This will be trip, red color will come. Now the relay is starting. So we are using the front port communications. I have connected a cross cable from my laptop to relay. In the back side also, that fiber optic communication port will be there. This is the OEM port, OEM AB and OEM CD. These 2 ports will be there. So here we'll see the front port communication. So in this display you can see setting is there. If you go to settings, general setting will be there. Next you come to communications, and in communication you see TCP/IP communication is there. Here front port and OEM port AB and CD will be there. So we are doing front port communication. So we'll see the default IP will be 10.1.150.3. So we'll set the IP address in that laptop and we'll see the communications. In our laptop we have to set the IP address, as the default IP in the front port is 10.1.150.3. So we are already, I set the IP address, you can see here. I'm going to go to this TCP/IP version 4. So 10.1.150.4 I kept, and I set the IP address in the relay, in the laptop. Now you want to make sure that your relay communicated, so you go to the ping options, ping 10.1.150.3. See, it is replying. So the relay is communicating now with the laptop. So we'll open that software and we'll see how to communicate with the relay. This is the IP settings in the relay to the laptop. Once we communicated with the relay, we have to create a structure like this, tree structure of adding different types of relay to a bay. So this is the project name what we are giving. D1 actually we are giving like J1, suppose we are giving means 33 kV voltage level. This is substation voltage level, again the bay and the bay equipment, like what are the protections we are utilizing. Substation level, voltage level, and what are the bay. This is the bay number actually. Q01 means that the bay 1. So if it is coming Q02 means it is bay 2, like that. So these are the protections, and what are the different equipments protections relay we are utilizing. Primary protection 1, primary protection 2. So like that, this D1 means that is a 220 kV substations. The voltage level is 220 kV. If it is coming J1, that indicates 33 kV. If it is coming C1, it will be 380 to 420 kV. So as per requirement, we can give it, but this is the standard actually we are utilizing. So this particularly nomenclature we are utilizing in the relay technical key. So this will be unique for each relay. And this is, suppose we are utilizing for BCU, this is for RET-670, and this is for RET-615, like that. So this is the structure actually you will find once the relay we communicated with the laptop.
I have opened this software now. You can see this is PCM 600 2.3 versions. So in this there is already we prepared one structures. Here you will see that before that you will see this is the technical key we are giving or we are assigning to the relay. There is an inbuilt technical key will be there, and in same way we have to assign in our requirement wise we can assign. This A1 is the one site, the D1 is the actually voltage level, substation voltage level. That's the bay number Q04, Q05, Q01, like that. First one is the BCU, second is the primary protection, second one is the backup protections. So in the software also you will find these are the bay 1, bay 2, bay 3, bay 4, like that. If you open any bay, you will find this is the BCU, this is the RET-670 main protections, the second is the backup protections. This is for the restricted earth fault protections. So like that I will create a new project by adding this relay. So I'll go for this new. So if I click new, it will ask to stop this or to close this existing projects. So it will ask to give a name. So I'm given as trial, create. Now I'll open it. Now in this you will see, if you click right, you will see that general substations. I am not giving any name, you can give it to any name. Now I'll add new general voltage level. Next I will add new general and the bay. Now I will add new. Next the type of ID or the type of relay we are reading. This is the transmission, this is RET-670 we are reading. So now we'll do the online configurations. Relay already communicating, so we'll add the online. So go to next. This is the IC 61850 protocols. Go to next. This is the actually front port will give 10.1.150.3. Now if you do, this is the scanning will come. Next you scan it. The ID type and product version will come. Now go to next. That housing type and display type will come. Now this RET already added to this structure now, and it will, if you click finish,